Hi, everybody. It is time for some practice. Now, I think depending on, honestly, depending on how old this video is, when I'm making this, I gave this worksheet out to everybody, and we're going to go through it and determine what kind of question it is. But I didn't take the time, and I didn't plan to take the time to work out each question. Now, hold on. Sorry. Need a black pen. Anyway, my hope is there's going to be a series of videos. I'm not really sure how many. Where I'm going to go through all the questions for you. So I actually have answers, which I want anyway, because, you know, it's lovely to know what kind of question it is, but it's a little more helpful if you actually know the answers. And then I'll be able to have the answer sheet for this too. So it's a win-win. And I thought I would make a video while I'm at it. All right. This is probably useful for you also. Here we go. Okay. So this is my big decision chart. If I get lost and if this doesn't make any sense, there's a different one on the back. And I don't know, whichever one makes you happy. It's exactly the same thing. It's just some key that says this is the type of question you have to use, because that's, you know what, it's a little bit like finance. If you don't get the right formula, the whole question's not going to work. Anyway, done talking. So there's our formula sheet. Okay, I don't know why I'm showing that to you again. Sorry, let's get started. A man has 3 sport coats, 8 ties, and 4 vests. How many outfits can he wear? I have to make choices. And the rule is you make a blank for every choice. This is pure, beautiful, fundamental counting principle. There, here's my, hold on, have a plan. If I can make this work so you can see both. But it's okay, because I have faith that you have the video too, or have the worksheet. All right, so number 1, counting rule. That's fundamental counting principle, P and C. So number 1. All right, so 1, 2, 3. He has to wear sport coat and a tie and a vest. So he has to choose 3 things. So we draw 3 blanks, and in each blank goes a number of choices. 3 sports coats, check. 8 ties, check. 4 vests. So he has to wear a coat and a tie and a vest. So we just multiply through to get our answer. I want to say 96, but I'm not sure. 3 times 8 times 4. Yep. 96 different outfits. I'm not going to write different outfits, but there you go. If you wanted to, I'll start it out. I'm not going to do the whole thing. You could go do a tree diagram. Start. Sport coat 1, sport coat 2, sport coat 3. Whoops, get in the picture. And then for each of these, tie 1, tie 2, tie 3, tie 6, tie 8. And then, where have I got room? I'm going to go from here. Vest 1, vest 2, vest 3, vest 4. You can see, okay, I'm just lazy because there's going to be 96 choices. I don't feel like drawing them all out, but it would be my first sport coat, tie number 4, and vest number 1. That's one choice. And then sport coat 1, tie 4, vest 2, and so on and so on. And if you count up all the ones at the very end, you would have 96 in total. But unless it says, give me all the options, or it says, draw a tree diagram, you don't have to. I will sometimes draw this if I get lost and I'm not really sure what's going on. Anyway, I'm just showing you could do it, but I don't want to. Question number 2. Question number 2 says, how many 4-letter permutations can be formed from the word decagon? Okay, how is that sweet? It says permutations. Boom, I'm already here. Are all the items different? Okay, so if I look at the decagon, there's no letters that are repeating. So then I can do NPR. And because everybody has a calculator that has the magic NPR button, we don't need that. So I don't have to. So, all right, I'm just gonna stop trying to show the question and the paper at the same time. So 4-letter, I'm having, excuse me, a moment trying to figure out whether it's important that you see the question or not. I think you'd rather see my words. Okay, so it's a permutation because the question said it's a permutation. And now we need 4-letter permutation. So it's going to be 4 letters. And we're using the word decagon. And that's 1, 2, 3, 4, 5, 6, 7 letters. So there's 7 letters, permute 4. Okay, so let's see if I can figure out how to use this calculator. 7, second function C. If you can see, permute is right there. Permute and 4, and boom, 840. Now, if you don't want to do it that way, you can also look at it in terms of you're choosing 4 letters. So 1, 2, 3, 4. This is my first letter, my second, my third, and my fourth. So if I start out with 7 questions, so there's 7 letters there. So when I pick the first one, there's 7 choices. Now, I can't repeat. I don't have an infinite number of these. So let's say I use the A first. Then I have 6. And I don't know, it doesn't really matter. 5 and 4. So let's see if 7 times 6 times 5 times 4. Yeah, same answer. Do it either way. It doesn't matter. This is just a few less keystrokes on your calculator. And when these numbers start to get really big, like, I don't know, 15 to permute 12 or something like that, it's a lot of numbers to have to type out, and I'm just lazy. So there we go. 7 permute 4. All right, question 3. How many ways are there to select 3 coins? Okay, so we're from a box containing a penny, a dime, a nickel. I know I read that backwards. A quarter, a half dollar, and a silver dollar. We are selecting. Hold on. See, this one, I almost don't like the question, because to me, it's not clear. Because to me, select is like choose. And there's really nothing about arranging. So to me, the question is not clear whether it's supposed to be a permutation or a combination. So I'm going to cheat. I'm going to do it both ways. But if I had to do this on a test, I would say it's probably a combination, because it's just you're taking them. It doesn't matter whether you get that penny first or last. You still have a penny. But I'm going to do it both ways. All right. So question 3. Don't mind me. penny, dime, nickel. So while I'm doing this, you can do the question. Quarter, half dollar, silver dollar. So which makes me think either this is a really old thing from Canada or maybe this is American, because it's been a long time since there's been a lot of silver dollars in circulation. Okay. Anyway, we are supposed to select 3. So select to me means combination. So combination. Now, combinations and permutations kind of work the same way. The first number, the n, is how many things I have to pick from. So 1, 2, 3, 4, 5, 6. And I'm going to double check 1, 2, 3, 4, 5, 6. Okay, so I didn't miss anything. 6, and I have to choose 3. So this means the order I pick them out doesn't matter at all. So 6, choose, there it is, 3, and that's 20 ways. Just for fun, because you know I like math. So if the order I pulled those coins out really mattered, I don't think it does, but just in case, then it would simply be 6 permute 3, which should be a bigger number. 6 permute 3 is 120. So I would go with this one because of the word select, if I had to choose. Depending on who my instructor was, I might put both and then hope they just like me enough to just ignore the one that was wrong. All right, here we go. Question 4. At the Rogue Film Festival, 8 films are shown. How many different ways can these 8 films be shown? All right. Well, this to me sounds like the order is going to matter, right? It's different whether you are the very first movie that's being shown or whether you're the one at the end. So that's a permutation. So number 4, 8 films. So that's going to be 8 of them, and we're going to permute 8. And I don't know what that is. It's a big number. 50, 40, I'm guessing. 8, second function, permute 8. I was off by an awful lot. 4, 0, 3, 2, 0. That's the lazy way. Okay. The slightly less lazy way is to realize that we have 8 things and we're arranging all 8 of them. So that would mean we'd have 8 blanks, 1, 2, 3, 4, 5, 6, 7, 8, and we would count down. And if we do that, 8. Don't judge me if you saw my lips moving. Boom. And of course you can't see because of this, the glare. Or, you know, stop giving us options. This was easy. Stop talking. You can also do it when you recognize you start at 8 and you multiply all the way down until you get to 1. It's also 8 factorial. So 8 factorial, 4, 0, 3, 2, 0. Any one of those is fine. I should point out on some calculators, the factorial, right, the exclamation mark, sometimes it's n factorial, sometimes it's x factorial. It in no way. They just switch it depending on the calculator. Who will? All right, So that's number 4. Question 5. Says 5 dice are rolled. How many different outcomes are there? Well, let's go with the easy one. Fundamental counting principle. 2, 3, 4, 5. They didn't actually say what kind of dice they are, so I'm going to go with my normal 6-sided dice. 6, 6, 6, 6. Now, you're wondering why it didn't count down. It's because I'm literally throwing 5 dice. So what happens on dice number 1 doesn't affect anything else. It's not like if I got a 6 on the first one, none of the other ones can be 6. So 6. I'm going to be lazy and I'm going to use my exponent button. 5th. 7, 7, 7. There you go. I'm starting to overthink that one. Okay, because we have to roll the first dice and the second, so we're just going to multiply all the time. I'm going to put a star there because honestly, I'm going to come back and overthink that one in a little bit and make sure I'm happy with my answer. Number 6. If a baseball manager has 5 pitchers and 2 catchers, how many different possible pitcher, catcher combinations can he field? Okay, so imagine you're the manager. What do you got to do? Well, first thing I'm going to do is I'm going to pick my pitcher, and then I'm going to turn around and I'm going to pick my catcher. So it says there are 5 pitchers and 2 catchers. 10. Ta-da! 10 different possible pitcher-catcher combinations. Oopsies. Number 7. A general manager of a fast food restaurant chain must select 6 restaurants from 11 for a promotional program. How many different ways can this selection be done? Okay, there's that crazy word select again. I'm thinking it's a combination. And part of that is because, so imagine there's 11 restaurants. It doesn't matter whether you're picked first for doing the promotion or last for doing the promotion, you're just picked. So order doesn't matter. So that means it's a combination. So there were 11 stores, and we're going to choose 6 of them for our promotion. I know C is supposed to stand for combination, but in my head, I always say choose because that's the word for me. So 11, choose 6 is 462. There we go. I know some calculators like mine is an older one, and a lot of them are really nice so that when you hit that choose button, you get a nice C there, and then this one doesn't. It just doesn't. But thank you, Value Village, for a calculator. All right, number 8. Ooh, look, right there. How many different permutations of the letters in the word Alabama are there? The alarms just went off because there's something weird about the word Alabama. I'm going to start talking like this. It's got some repeats in it. And there's this, sorry, I'm gonna stop that. And there's a special formula for it. So there's a permutation and there are repeats. Then you take all of the letters and then you're going to factorial, and then you divide by the factorial of your repeats. So I'm just going to write Alabama first. Okay, so there are 1, 2, 3, 4, 5, 6, 7 factorial. So 7. This is my total number of letters. And now repeats. I've got 1, 2, 3, 4. 4 factorial. And that's with A's. So repeats go on the bottom. And if I look at what's left over, there's an L, a B, and an M. I don't have to do anything with them if there's only one. You can just ignore them because like 1 factorial is 1. So 7 factorial divided by 4 factorial is 210. I like the fact that we can just do that. So there's 210 different ways that you can, rearrange that. All right, what question are we on? Question 9. That's, look, if I think I should have checked what time it was when I started this video. I think we'll do 2 more and then I'll end the video because you don't want the videos to be like silly and crazy long. All right, number 9. A corporation president must select a manager and an assistant manager for each of 2 stores. The first store has 9 employees and the second store has 7 employees. How many different ways can this selection be accomplished? There's that word selection, but I'm not trusting it this time. Because I think about, okay, I'm the president. I got 2 stores now. So that's going to be different. So I got to have at least 2 blanks, right? 1 for each store. But I need a manager and an assistant manager. Question, is that the same job? No, because then they just call them co-managers or 2 assistant managers or something, right? So those are different things. So order is going to matter. I suspect the guy who's a manager gets more pay than the guy who's, or girl who's not a manager. So those are different things. So I'm thinking store number 1, manager, assistant manager. And then we have manager, assistant manager, store 2. Also, we know that the first store has 9 employees. And the second one has 7 employees. It doesn't say anything in the question. I'm just going to bring it back for a second. So I'm going to make the assumption that each one of those 9 employees has an equal chance of becoming the manager or the assistant manager. I don't know if they really do, but I'm going to make that assumption because the question doesn't say anything. Yeah, can leave it like that. I'm overthinking. So I'm going to pick my manager. Whoopsies. And then to get my assistant manager, there's going to be 8 people left. And then I'm going to go to store number 2. And there's 7 employees there. So that's going to be 7. I'm going to pick 1 to be my manager. And I'm going to have 6 left over. So 9 times 8 times 7 times 6. 3024. 3,024 ways that the manager can pick or sorry, the president can select the managers and assistant managers from the 2 stores. Next one, number 10. Dum, dum, dum. Oh, this is a good one. You know why I say that? It's got the dreaded at least. At least, not more than, less than, greater than, all of those inequalities, like, means the question's probably going to have cases. There's going to be different options. So we have 5 flags. And you must select at least 3. Okay. And here we are stuck again. Here I am stuck again, trying to figure out whether that's a permutation or a combination. Does the order of flags matter? Because it might matter whether it's red, blue, green, or green, blue, red. And what are we doing with these flags? So, you know what? I'm going to do it both ways. Combinations. I'm leaning towards, because they use the word select, combinations. But from everything I know about when you're using multiple flags, the order you see them does actually matter. So, which makes me think I want to rewrite these questions and make it more clear for you. All right, so combination, this part, that whole at least, that means 3 is good. 3 flags is wonderful. So we could have 5 flags and we can choose 3 of them. There we go. So 5, choose 3, and it's going to be 10. But because it says at least, then 4 flags. If I say I want at least 3, then 4 is fine. I can also have 5, choose 4. And I'm pretty sure that's 5. 1, choose 4. Or I could just be a crazy person and use them all. 5, choose 5. And I know that's 1. There's only one way to use all the flags. 16. Now, the reason I'm adding, and you're like, but we're multiplying all the time, all over the place. It's crazy. We're always multiplying. Yes, but you can't have 3 flags flying and 4 flags flying at the same time. So these are different cases. So when it's this or this or this, so if you're going or in between, then you usually add them up. When we did this one about the stores, we had to do the manager and we had to do the assistant manager and we had to go to the other store and do the manager and we had to do that. Then there's multiplying. It's pretty subtle, but do the best you can. Now, this is my answer based on the question. Based on what I know about flags, and I can say I sailed for a year, we used the flags, showing people what it meant. Order does matter, in which case it's just going to be 5 permute 3 and 5 permute 4 and 5 permute 5. And I know we always get more when we have permutations. So 5 permute 3 is 60. and 5 permute 4 is 120. And I think 5 permute 5. Whoops, messed it up. Sorry. 5 permute 5 should be 120 also. Okay, and if that looks weird, that these two are the same, think about it. 5 permute 4 means we have to draw 4 blanks. 1, 2, 3, 4. We're arranging 4 things and we start at 5. 5, 4, 3, 2. 5 permute 5. This is the number of blanks I draw. 1, 2, 3, 4, 5. So I got 5 flags and I start counting at 5, 4, 3, 2, 1. So the difference there is the 1, and 1 times anything doesn't change my values. Sorry, got a little chalk there. 120 plus 120, that's 240, plus 60 should be 300. 300 different ones. So you can also see we can provide a lot more information if order matters than if it doesn't. And that's the end of the video. There hopefully will shortly be video number 2 that starts on question 11, and we'll see where we go. Thank you and have a lovely day.